It all started with a really big bang. That's how energy was first created, spreading across the universe, fueling stars, creating planets, and everything in between. But here's the thing, energy didn't disappear. It's still stored in everything around us, a body, plants, or even the soil beneath our feet. All of it is made up from the same energy, just stored in different forms. So, when I say the word smartphone, many of you might think that it's only the battery inside the smartphone that is a store of energy. But it's not just the battery. The plastics, the metal chips, and even the screen, every part of your phone is a store of energy in one form or another. However, it's not always feasible for us to convert all of this stored energy into something usable. So while we cannot burn the things around us, we can tap into the energy stored in more practical ways that can power up our everyday lives. Now there are a total of 8 key stores of energy that can help keep our world powered up. The first one is the chemical energy. It is the energy stored in each and every bond of atom and molecule, like it is present in the food we eat or the batteries that power up our devices. Next is the kinetic energy. It is the energy of motion. Anything that moves, from a racing car to a bullet, it all stores kinetic energy. Next is the gravitational potential energy. It is the energy stored in the object due to their height. So it might be a roller coaster at the top of a hill or a border reaching at the edge of a cliff, waiting to fall. Both store energy as gravitational potential energy. Next is the elastic potential energy. It is the energy stored when objects are stretched or compressed, something like a rubber band ready to snap or a spring about to bounce back. Both store elastic potential energy. Next is the thermal energy. It is the energy that comes from heat. So whether it's the warmth from a heater or a fire in a campfire, both store thermal energy. Next is the magnetic energy. It is the energy stored in magnetic field, like the force that pulls a magnet together or something that powers up a compass. Next is the electrostatic energy. It is the energy stored in electric charges, like the static shock you feel after rubbing your feet on the carpet. And last, we have the nuclear energy stored in the nucleus of atoms. It is incredibly powerful force that powers up a sun, nuclear reactors, or even a nuclear bomb. But energy doesn't sit in one place. It moves and transforms from one store to another. This is where the principle of conservation of energy comes into play. Simply put, energy cannot be created nor it can be destroyed. It only changes from one form to another. Let's start with one of the most incredible examples of energy transformation. So let's start with the sun. Inside the sun, nuclear reactions release a tremendous amount of nuclear energy. This energy radiates outwards at sunlight. It gets converted into heat and light energy, travels across the space to reach Earth. So when this sunlight reaches Earth, it warms up our ocean, transferring that heat energy into water. Now this heat causes the water to evaporate, turning it into water vapor. Now the energy stored in water vapor is gravitational potential energy as it has gained some height. Eventually this water vapor condenses as clouds and falls as rain, transferring that gravitational potential energy into kinetic energy as it flows down the river. And these rivers power or hydroelectric dams where kinetic energy is converted into electrical energy. Now this electrical energy travels through power line and ends up in a home, powering everything from a smartphone to our lights. So what started as nuclear energy inside the sun is now powering up the devices we use every day. In this entire journey, energy has taken many forms, starting from nuclear energy, heat energy, light energy, gravitational potential energy, kinetic energy, and finally the electrical energy, all while following the principle of conservation of energy. Now for better understanding, let's go through another example. How does gasoline powers up your car? So it all starts with the chemical energy stored in gasoline, which is made up of complex molecules. So when you turn on your car, The chemical energy is released through combustion, transforming into heat energy inside the engine. Now, the heat energy produced by combustion doesn't stay as heat, it gets converted into kinetic energy, which powers up the moving parts of the engine, causing the car wheels to spin and the car to move forward. But that's not all. Some of the energy from the combustion process is released as sound and thermal energy, which we can hear as the sound coming from the engine or the heat coming from the car engine. In this journey, again, energy starts as chemical energy stored in gasoline and it transforms into heat energy, kinetic energy, and sound energy, keeping the car moving while following the principle of conservation of energy. So, whether it's the energy from the sun powering your home or gasoline powering your car, the principle of conservation of energy always works. Energy never disappears. It changes form, moving from one store to another, fueling everything around us. Now, thank you for joining us on this electrifying journey. If you learned something new from this video, don't forget to hit the like button and subscribe to our channel, My Exam Revision, for more videos like this. But before you go, I have a mystery question for you. Imagine the energy stored in the lump of coal deep underground. Now, what form of energy does this coal need to go through before it ends up powering up the lights in a home? Drop your answer in the comment section below and I will leave a like on the correct answer. Thank you.